Now you can check that out. It may be somewhat better than that previous one. Yeah? Yeah, clear. Okay. It means that depending upon your speed, we can change. Yeah? Okay, depending upon your internet speed, we will change the speed here. Okay? Right, we'll just solve some of the numeric problems and then come back to that. Okay? Now, because basically if you don't understand the convention, signing convention, how to apply that, how to study the results, how to infer from that, it's very difficult to proceed further. Okay? So first to learn that, then we'll come further. And once you learn this one, any sort of problems or worksheet will be easier for you. Right? Now take this one. The mirror, a convex mirror used for a rear view on an automobile has a radius of curvature 3 meters. A bus is located at 5 meters from the mirror. Find the position, nature and size of the image. So these are the data given here. So convex mirror we are using here. Okay. So remember that the basic points you have to remember. What is the radius of curvature? It is given clearly. What is the radius of curvature? It is 3 meters. So since it is a convex mirror, for convex mirror, you know that a convex mirror, if you take a part of this spherical lens, the shining part is here and shaded part is behind that, whatever you take, in whichever part you take. Now when you are measuring the radius of curvature, we take this as behind the mirror, isn't it? Measuring this radius of curvature for convex mirror will be behind that. Since it is right side of the mirror, it should always be taken as positive. Should be taken as positive, right? If it is concave means it has to be taken as negative, because for concave we will take the polished side this side and the radius of curvature this side. So it is left to that mirror. So it should be taken as negative. So the very first point is very important, that the radius of curvature should be taken as positive here, plus 3.00 m. You may ask why is it given as 3.00? Because we may use 2 digits for the some of the points or answers. That is why it is given as correct to 2 decimal points. Now the object distance. What is the object distance? It is nothing but the image is located, isn't it? The object is located at 5 meters. So the object distance is taken as u and is 5 meters. And what is the question? Image distance we have to find out. Also the position, nature and size of the image we have to find out. Right. Now we know the formula, how to relate this focal length and the radius of curvature. F is equal to R by 2. Isn't it? R is equal to 2F. We know that. Using that, we can take radius of curvature and divide by 2, so that you will get plus 1.50 as focal length. Okay, so this focal length is also plus, because as I said already, the radius of curvature, half of the radius of curvature. Since radius of curvature is also positive, half of that will become 1.50 plus 1.50. Okay, now let us come to the mirror formula. Using that mirror formula only, we are going to find out this value of V. Okay, so what is the formula? Mirror formula says that 1 by V plus 1 by U is equal to 1 by F. So in this we know the value, U value we know, object distance we know, and focal length also we know. So these two values are known to us. So by using this, what can we do? We can take the unwanted variables on the other side. So we can keep as it is, 1 by V as it is, and take this 1 by U on the other side. So it becomes 1 by F minus 1 by U. Right, now we can substitute the values. So what is the value? The focal length we have taken, it is 1 plus 1.50. In the object distance, that is U is taken as negative, minus 5.00, isn't it? Because to the left hand side, left side of the mirror, so it should be taken as minus. And already one minus is there, this minus into minus will become plus. So this point you have to note down. And the next one is 1.5 and 5. So we have to take the LCM for both this. So usually we know that by just multiplying you can take the LCM, 15.5, so 7.5. So cross multiply that, 1 into 5 and 1.5 into 1. So 5 plus 1.50, it is nothing but 6.75. So the value here, numerator 6.75 and the denominator is 7.50. Since we need only V, we have to take the reciprocal of that. So it will become 7.5 by 6.5. When you just calculate that, we will get 1.15 meter. So the value of V, that is image distance, is plus 1.15. Now what do you understand from this value, plus value? By looking at that value plus 1.15, can you just imagine whether the image is in front of the mirror or behind the mirror? Is it a virtual one? If the value of V, that is image distance, is positive, I am asking if the image is given as positive plus 1.15, in which side of the mirror the image will be? Because the mirror, convex mirror, will be like this, you know that. So this is the convex mirror, this is the coated portion, and this is the reflected portion. Now tell me, they say that object is, you know that, what is the object distance? 1.5. In front of the mirror it is at 1.5 meters. Okay, now object will be plus, means it should be behind the mirror. Okay, so the location we have understood now. Since it is positive, positive means always on the right side of the mirror. So that way you have to remember. So it is plus 1.15, so the image should be behind the mirror. So the image is 1.15 meter at the back of the mirror or behind the mirror. So this is the location of the image you have to remember. And the next point, we have to see about the size, virtual or erect or smaller or bigger. For that we have to take the magnification formula, m is equal to h dash by s, h or minus v by u. The value is minus v by u. Minus is already there. The v is already given. We have found out that it is positive. So it has to be taken as plus 1.15. You have to remember that, to mention it is as plus 1.15. And the object distance is in front of the mirror. So it should be taken as negative. So minus 5.00. So just you have to divide this. So by dividing this, what will you get? Already this is minus and this is minus. So it will become plus. And if you divide 1.15 by 5, you will get 0.23. So now we can see that the value of this is less than 1. Isn't it? So if it is less than 1, if it is 1 means size is same as the object. If it is greater than 1 means it may be magnified. Since it is less than 1, the image, that is the magnification, is diminished, we can say. It is smaller in size by a factor 0.23. 0.23. And these values, how to find out these values? Since it is positive, it is virtual one. Yeah. Since the value of magnification is positive, we say it is virtual one. Okay. And it is erect because behind the mirror, if the image is for convex mirror, we know that the image is behind the mirror and definitely it will be erect one. Okay. So the values we have to remember. First we have seen the image is formed behind the mirror. That one point we have to remember. And the second, the nature is virtual and erect. And third one, in about size, it is smaller by a factor 0.23. So these are the 3 points you have to remember. So in all these numerical problems, only 2 things are involved. One is the mirror formula, the other one is the magnification. Using these 2 formulae, we can easily solve all the numerical problems very easily. But provided if you are very thorough with the sign conventions. Okay, now let us take the next problem. Look at that. Though the problem is somewhat looking bigger, the solution is very easy only. An object 4.0 centimeter in size is placed at 25 centimeter in front of a concave mirror. Now here we are talking about concave mirror of focal length 15 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? That is, they are asking the distance of the image, at what distance it is formed, and nature and size of the image. Similar to the previous one, but only thing is the mirror is different. Earlier it was convex, here it is concave. Now we have to remember, for concave mirrors, what are the sign conventions, how the focal length should be taken as positive or negative, image distance, all these things you have to remember. Now look at that. What is the data given here? The object size is given because the first one is 4.0 centimeter in size. So object distance is h. So the object distance is h. It is measured above the principal axis. So it should be taken as positive 4 centimeter. And the object distance, remember that. When you are placing any object in front of a concave mirror, you are measuring that to the left of the mirror. So it should be taken as negative, minus 25 centimeter. And similarly, focal length is also minus because earlier, already I told you that for concave mirror, right? This is the center, that is center of the center of curvature, and this is the pole, and half of this is the focal length. This is f usually, isn't it? Now when it is concave, this side is shaded one, right? Now we are measuring the focal length to the left of the mirror. So when it is left of the mirror, this f should be negative, that is minus 15.0 centimeter. So once you remember these points, plus, minus and minus, the other things becomes very easy. Okay, now image distance easily we can find out, and the image size also we can find out. Okay, how to find out the image distance? Let us see. How to find out image distance? By using the same mirror formula. 1 by v plus 1 by u is equal to 1 by f. Again, what will you do? We have to retain this 1 by v and take this 1 by u on the other side. So it will become 1 by f minus 1 by f, 1 by u. Again, substitute the value. F we have taken as minus 15 and u is also minus 25. Already one minus is there. So minus to minus will become plus here. Okay. And now this minus, for this minus we have kept it here. Okay. And this minus is here, minus 5.0. Okay. What is the LCM we have taken here? 75. Hope you are thorough with the LCM. Isn't it? Yes or no? Yeah? Okay. So since it is, we have taken 75, so here it should be 5 times, here it is 3 times only. So 5 plus 3. Okay, this is minus minus plus, and here it is minus. So minus 5 plus 3, it becomes minus 2. So minus 2 by 75. And when you take inversion, that is reciprocal of that. So it will become 75 by 2, which is nothing but 37.5, and here it is minus, so we are taking minus. Now tell me, from this value, v is equal minus 37.5, now tell me about the image. Which side is the image located? Which side is the image located? Front of the mirror. That means to the left of the mirror. Okay, to the left. If your mirror is on the right side, to the left of the mirror. Okay, you have to say to the left of the mirror. Okay, because if the mirror is kept like this also, okay, the mirror can also be kept like this, but this is also front only, right? So better you say, always we say that the object is kept left side, and here for this kind of mirror, the image is also on the left side. So say to the left of the mirror, 37.5 centimeter from the mirror, the image is a real one. The image is a real one. Why? Because, can you tell me why do you say that image is real one? Also, without seeing that also we can say, because for concave mirrors, if the object is placed at a finite distance, definitely the image can be caught on the screen. So it should be a real one. Okay, without that also we can say the image is a real one. Okay, right. Next, by using this magnification formula also we can say, here the value, you know, that minus v by u, and from that we can say the value of h distance, because in the question they are asking the height of the image also, isn't it? So when you are asked to find out height of the image, you have to use this formula, h dash by h. From that we want h dash only, so we take h on the other side. So it becomes minus vh by u. And we know, just now we have found out the value of v is minus 37.5, and h value already given in the very first line of the question, which is 4.0, and u value is also known because this is only object distance, which is minus 25.0. So by looking at that, we can say minus into minus will become plus, and here the minus is there, and 37.5 into 4 is 150, 150 by 25 is 6, and since it is minus, plus divided by minus will become minus. So h dash is minus 6.0. The height of the image is minus 6.0. If the height of the image is minus, right, when you divide this h dash by h, what will you get? H value is, what is h value? It is 4, plus 4. This is plus 4, and here it is minus 6. Minus 6 by plus 4 will naturally become minus only. So the magnification value is minus. Since the value of magnification is negative, definitely the image is inverted. It is inverted. How can you say it is enlarged? How can you say it is enlarged? Because magnification is h dash. How much is the h dash? Minus 6 by 4. It is minus 1.5. Isn't it? So it is, how can you say diminished? It is more than 1, you know. Since it is more than 1, it is enlarged one. It is not diminished. Okay. No, don't talk about that. This minus value is only for the indication of the real or virtual image, whether it is inverted or, you should not take like that, man. I told you that these signs we are talking about here is only to find out whether it is inverted image or real image or a virtual image, like that. We have to say the magnification factor only. Okay, the magnitude only we have to see, the value only we have to see. It is 1.5 times. Okay, it is 1.5 because we compare the 6 by 4. Okay, the height of the object is 4, the height of the image is 6. 6 by 4 is 1.5. These signs are only convention signs, sign convention, Cartesian sign convention. That is only to understand whether the image is real or virtual. So here, since it is negative, means it is virtual one, real one. For negative it is real, for positive it is virtual. Okay, so a real image, inverted one, and enlarged. Enlarged we can say by a factor 1.5. By using this we can say it is enlarged by 1.5. So these are the points you have to remember. Right. The next one is, a concave mirror produces 3 times magnified real image of an object placed at a 10 centimeter in front of it. Where is the image located? Where is the image located? So by just imagining a concave mirror is there, okay, it is producing 3 times magnified real image of an object placed at 10 centimeter off from it. From here it is, the object is placed at 10 centimeters. Okay. Now what is the question? It is producing, magnification is given, 3 times it is given. Okay. Now object distance is given, magnification value is given. By using these data, we have to find out where is the image located. Where is the image located? Now see that, what is that they have given? 3 times they are given. That means the magnification, yes, m is given. Okay, m is 3. But here I am not taking as it is, but I am taking it as minus 3. Do you know why? Because it is a real image. Because it is a concave mirror, the image is a real one. So I have to take it as minus 3. Magnification, if it is real image, the magnification should be negative. You have to remember that. By mistake, if we take as it is 3, answer will become wrong. Okay, this is what the important point you have to note down. So magnification is -3 for real image. And similarly, object distance is given because it is at a distance of 10 centimeter from the mirror. Since it is object is in front of the mirror, to the left of the mirror, we have to take it as -10. And we have to find out the value of V. So very simple that we have to use the magnification formula. Very simply we can substitute the values. M is equal to -V by U. M we know -3, and here object distance is also known -10. Simply multiply this, cross multiply, -3 into -10. So -V is equal to -3 into -10 will become minus into minus is plus. Since it is -V, I take plus V as -30. Okay, -V is equal to plus 30 and V is equal to -30 centimeter. It means that again, since V is also minus, the image is located at a distance of 30 centimeter in front of the mirror. Image is located at the 30 centimeter in front of the mirror. Yeah? Is that clear? Are you copying or doing some other work, Varun? Yeah? Okay, done, good. Right. Okay, then. Now let us go to the next one. But remember that you try to understand the concept. Once you have understood, just without looking at that you can solve the problem. Never try to copy something, okay? Try to understand first. It's very simple only. Next question is somewhat lengthier but very easy only. All the problems are following the same procedure. Now see, we wish to obtain an erect image of an object using a concave mirror of focal length 15 centimeter. Here remember that concave mirror we wish to have erect image, not inverted, okay? Remember that. Now can you imagine the point which you have studied about concave mirrors? There are 6 points, 6 positions of the objects we have located the images. Do you remember the tabular column? In that tabular column, right, which point, which location of the object produces erect image? Do you remember that? At what position of the object a concave mirror will produce erect image? If you look at the tabular column, remember the tabular column. You have to record it as a picture. Just if you close your eyes, you can just read all the 6 points. At what position the image will be erect one. Try to recollect that, okay? And what should be the range of distance of the object from the mirror? If they are asking the distance of the object, at what distance you have to place? Exactly, very good. Between the less than the focal length, actually. We say between the pole and the principal focus. It means that it is less than the focal length, isn't it? Because we know that the focal length is nothing but, this is pole, this is center of curvature, this is principal focus. It means if you are keeping somewhere here, it means this is only focal length. So we are taking less than the focal length. Anywhere in between F and P means the object should be placed with a distance less than its focal length. So if you remember that, the points becomes very simple. Very good. You are able to remember that. Now the next question is the image larger or smaller than the object, and then they are asking us to draw the ray diagram to show the image formation in the case, okay? For which you have to remember the ray diagram. Let us see how to write the answer. So as you have already suggested that the object should be placed between P and F, that is between the pole and the principal focus. And the distance between P and F, as I told you, it is nothing but the focal length. So when you are keeping in between these two, here the focal length is given as, yes, the focal length is given as 5 centimeter. So that the object should be placed at any distance which is less than 15 centimeter, isn't it? Is it 15 or 5? It is 15 centimeters, isn't it? So it should be 15. So it should be anywhere between the F and P less than 15 centimeter. Okay. So if it is kept like that, we have already discussed that when it is very closer to the when it is very closer to the concave mirror, you can just remember it as a plane mirror, for which I have told you already. You can compare that with the shape of the earth, all those things we discussed on the other day. When it is very closer, isn't it? The spherical shape will look like a plane one. So it is like looking at the mirror. So the image will be virtual. Virtual means it can be seen on the mirror, behind the mirror. And the image will also be larger than the object. Okay, this point you have to remember from the 6 points in the tabular column. Okay, using that you can write straight away. The image will be virtual. Image will be larger than the object which is behind the mirror, for which we can draw the ray diagram. Very simple one. Look at that. So this is the mirror, principal axis. The object is placed between pole and the principal focus. Now the image is formed behind the mirror, which is somewhat enlarged. Yeah, that's all. So virtual, erect and enlarged. It's very easy to locate. Is it clear now? Right? This is the point you have to remember from the tabular column. Between P and F, the position of the image is behind the mirror and it is enlarged, virtual and erect. Okay, these are the points they are asking you. Okay? Is it easy? Have you understood this? Okay. The next one, an object is placed at a distance of 10 centimeter from a convex mirror. Here we are talking about convex mirror. By looking at that, you have to just follow the sign conventions. Okay, once they say convex lens, automatically the sign conventions you have to follow. The focal length is 15 centimeter. They are asking you to find the position nature of the image. So let us take the data. Object distance is given. What is that? It is 10 centimeter. So when it is object distance, it is in front of the mirror. It should be taken as minus, left to the left of the mirror. Okay. So we can mention it here also in the bracket, to the left side of the mirror. So it is negative. And focal length is positive because it is convex mirror. For convex mirror, the focal length is positive. Okay. Because it is behind the mirror. Okay. Principal focus will be behind the mirror. And we have to find out the image distance V. We have to find out the image distance. So what is the formula usually? The same formula you have to use. 1 by V is plus 1 by U is equal to 1 by F, or 1 by E is, we have to take this 1 by U on the other side. It becomes minus 1 by U. Substitute the value now. So what is the focal length given? It is plus 15. It is plus 15. This minus is as it is there. And U distance is minus to the left of the mirror, so it is minus 10. So this minus to minus will become plus. And you take the LCM, it is 150. Cross multiply that, 10 and 15. 10 plus 15, 25. So 25 by 150, take the reciprocal of that, you will get 6 centimeter. 6 25s are 150. So the image distance is 6 centimeter. What happened? Are you there? Okay. Image distance is 6 centimeters. Is that clear now? So from this image distance 6 centimeter, you can clearly say that since it is positive value, positive. Also remember that it is positive means the image is on the right side. That means behind the mirror. Okay. So by looking at that only, we have to say the image is behind the mirror, 6 centimeters behind the mirror. And it is a virtual one because since it is behind the mirror, we can see the image in the mirror. So it is virtual one. We cannot get that on the screen. And it is erect one. And it is diminished one. And it is diminished one. Right? So these are the points you have to remember about the image. The next question, very important, a very interesting question also. Okay? The magnification produced by a plane mirror is +1. What does this mean? What do you understand by this term? The magnification produced by a plane mirror is +1. Okay, here only the points comes. What are the points we are going to discuss is, it is plus, that sign we have to see. And it is 1, the number we have to see. These two numbers will tell you something. What is that? A positive sign in the magnification value. The magnitude of magnification, if it is positive, that means that the image is virtual. Image is virtual. And it indicates that since it is 1 same size, because since it is 1 means the height, because magnification is nothing but h dash by h, we know that. It is h dash by h. When you say it is 1, when can you get 1? If both are, the numerator and denominator both are same only, we can get 1. That means the height of the object and height of the image both should be equal. Then only we can get 1. So from that we say that since the magnification value is 1, the size of the image is same as the size of the object. So this is the point we have to remember, okay, from this one. Or we can even mention also, since m is equal to 1, that means h by h dash is equal to 1. This point you can note down here. So you can easily add that and say h dash by h is 1. So the image is same as the size of the object. So that is the second point. Okay. And third point is the one which is related to plane mirror. So the image produced by a plane mirror means it is virtual, erect, same as the size of the object. This is the important point. This only tells about that, +1. Virtual, erect, and is same as the object size or size of the objects. Okay, these are the points which is talking about this value, +1. Okay, for plane mirror. Is that clear now? Have you understood this? Okay. Let us go to the next one. An object 5.0 centimeter in length. Okay, object length is, height is 5 centimeter. It is placed at a distance of 20 centimeter from a convex mirror. Here it is convex mirror, so follow the convention, sign convention. And the radius of curvature is given as 30. Find the position of the image, nature and size. These are the things they are asking. Same formula, only mirror formula and magnification formula we are going to use. But the convention, sign convention, look at that. Object height is given. It is 5 centimeter. Okay. Object distance is to the left of the mirror, so it should be negative, minus 20 centimeter. Okay, to the left of the mirror. Okay. Radius of curvature for convex lens, the radius of curvature should be positive, because we are measuring side from the behind the mirror, so it should be positive. You have to calculate V. Okay. So just follow the formula. What is the formula to find out focal length? Because we are going to use a mirror formula, for which we need F. To find out F only, they have given R. So F is nothing but R by 2, which is 30 by 2 is nothing but 15 centimeter for convex mirror. So it is plus. So we have got F now. So we follow the mirror formula, 1 by F. Use this formula, 1 by V plus 1 by U is equal to 1 by F. From that again, 1 by V is equal to 1 by F minus 1 by U. Now substitute the values. So what is the value of F? Focal length is plus 15. Image distance is minus 20. Already minus is there. Minus into minus will become plus. Now what is the LCM we have taken? 15 2. So we have taken 60 as the LCM. So 4 times 15 is 60. So 4 into 1 4. Similarly 3 times 20 is 60. 3 ones are 3. So 4 plus 3 is 7. 7 by 60. So take the reciprocal because it is 1 by V. So we take V is 60 by 7, which is nothing but 8.57. But here the value is positive. If we say that V is positive, it means that the image is behind the mirror. The image is caught behind the mirror. Cannot be caught actually, it is virtual. The position of the image is, we say, 8.57 centimeter behind the mirror. Since it is behind the mirror, we say the image is virtual and erect. This is the point you have to remember. Since it is behind the mirror, the image is virtual and erect. Now let us see the size of the image. How to find out the magnification? It is V by U. Image distance by object distance. Plus 8.57 by minus 20. Okay, already minus is there. So minus and minus will get cancelled. So 8.57 by 2, 0. So it is less than 0. Though it is positive, it is less than 0. Positive sign indicates that, what do you understand by positive? Is it virtual or real image? It is virtual. Opposite to that. If it is negative means it is real. If it is positive, the image is virtual one. Okay. So M is 0.42. So from that we can say that it is diminished one. It is not a magnified one, isn't it? Size of the images, size is magnification factor is 0.42. Right. Now, what is the question they are asking? They are asking you to find out the height of the image also. To find out height of the image, we use this formula h dash by h. So M is equal to h dash by h. Use the value here, h dash by h. H value is given in the first line of the question. Object length is 5 centimeter or 5 meter. So substitute that value. H is by cross multiplying this. So 5 into 0.42, which is nothing but 2.1. So the height of the image is 2.1. Height of the object is, you know that how much is that? 5. So when you compare these two, tell me whether the image is diminished one or enlarged one. Diminished, that's all. Right. The next question. An object of size 7 centimeter is placed at 27 centimeter in front of a concave mirror. Remember that it is concave mirror. Okay. For concave mirror, what are the sign convention? We'll follow that. And the focal length is given as 18 centimeter. Now at what distance from the mirror a screen should be placed so that we'll get a sharp and a focused image on the screen. Also find the size and nature of the image. Same like a question. Okay. Now what is the question? Here they are using a concave mirror and they are asking us to find out the location of the image and the nature of the image. Now substitute the values, data, find out the data first. Take down the data. Object distance U is equal to minus 27. Why is it minus? Because it is concave mirror. Okay, concave mirror is minus to the left of the mirror. And image distance should be calculated. We have to find out at what position the object should be, image should be got, screen should be placed. That means when you say that when the screen should be placed, that is the location of the image. They are asking us to find out the location of the image. And focal length is given. For concave mirror, the focal length is to the left of the mirror. It should also be negative, minus 18. Now height of the image object is given, 7 centimeters. Height of the image we have to get, h dash we have to get. That's all. So by using these data, we'll find out, what will you find out? We'll find out V. By finding out V, we'll take a magnification formula. From that we'll find out h dash, similar to the previous one. Now look at that same formula. 1 by V plus 1 by U is equal to 1 by F. Substitute the values. What is the value? 1 by V is equal to minus 1 by 18. Because why it is 18? Why is it 18? Because the focal length is negative. So I have taken it as minus 18. Because it is concave mirror. And similarly, the object distance is also negative. You should never miss these points, minus here also, minus here also. And in between the minus already there. So these minus into minus will become plus. And this minus will be as it is. Now take the LCM for 18 and 27. You know that 18 and 27, to take LCM, 18 and 27, take by 3 times. Again take by 3 times. Now multiply these two, you will get a 54. Okay. So this 54 we have taken it as LCM. Now multiply this. 18, 3 times 18 will become 54. So 3 minus 3. And similarly 2 times 27 will become 54. Here 2. 2 ones are 2. So minus 3 plus 2 will become minus 1. So minus 1 by 54. So when it is minus 1 by 54, if you take the reciprocal, it is minus 54 by 1. So it is minus 54. So the V is, image is at a distance of 54 centimeter in front of the concave mirror. Because it is concave mirror, V is negative means it is in front of the mirror. For concave mirror, the image is obtained in front of the mirror. Except the last point, 6th point, for all the other positions, the image is in front of the mirror. So it is minus 54 centimeter. Okay. So this is the point you have to try up to this one. There are other things, the nature of the image, we know that. What is that? It is a real image because we are going to get that on the screen. At 54 centimeter, if you place the screen, you will get the image. It is real one. And since it is a concave mirror, it is inverted one. So these 3 points you can write. And apart from that, we will see the size of the image. Size of the image and the height of the image. See that? What is the formula? Magnification factor, using that h dash by h, which is nothing but minus v by u. Right? Straight away we can take h, because here we are not asked to find out the size of the, that is magnification factor. Okay, so directly we can find out h dash. So how to find out? V just now we have found out it is minus 54, and u is already given, it is minus 27, and height of the object is also given, it is 7 centimeter. By simply substituting that, we get h dash is equal to minus 54 by 27 into 7. Okay, because 54 by 27 is 2, isn't it? It is 2. Minus into minus will become plus. Already one minus is there, that minus will be there. So it is minus 2. This value is minus 2. And this, if we take cross multiplication, minus 2 into 7, it is minus 14. So h dash is minus 14. When you say that the value height is minus, okay, when the height is minus, what do you understand from that? Okay. What's your doubt here? Okay. Do you have any doubt in this? You can ask. Yeah. Noted? Okay. Now the next one is we have to find out the height of the object. For that height of the object, h dash by h is equal to minus v by u. That magnification formula, m is equal, that formula only we are using. Here we are not asked to find out m, so straight away we are taking h dash. So h dash by h is given 7, and v just now we have found out 54. Object distance is given minus 27. By simply substituting this, minus 54 by minus 27 is 2. Already this minus is there, the same minus, so it is minus 2. This value, whole value will become minus 2, and this 7 will be cross multiplied. So h dash is equal to 7 into minus 2, which is minus 14 centimeter. The value minus 14 centimeter, the size of the image is minus, that is This indicates only whether the image is got above the axis or below the axis. For that only this sign. But the size of the image is 14 centimeter. That point only we have to remember. Okay? The size of the image is 14 centimeter. Since it is in front of that, it is virtual one. Okay? Got it? Shall we go to the next problem? Yeah. That's all. Up to this, what are the questions given? It is over. The next point is that we will discuss in the next class, which is the new topic, refraction of light. Okay, so far we have seen about the reflection of light only. The next one is the refraction of light. Refraction, you know that the light has to pass through that and it will move away from the path. That will deal in the next class, in which we will be studying about the same concept and also sign conventions regarding the lenses. Instead of mirrors, we will be talking about lenses. Okay, that we will see in the next class. Yeah, thank you. Mirrors only will reflect the light. First of all, you have to understand what is refraction, isn't it? For refraction,